Is it fine now? Can you hear me?
Yes, we can hear now.
Okay, so I should start now. Thank you for giving me this opportunity to present on the MMNOG 7th conference. So I will be presenting about the BGP best practices. Before I start, just to go through the agenda and about my introduction. So my name is Imtiaz Sajid, and I'm working with APNIC as a network analyst and trainer. So in this presentation, I would be talking about the introduction to BGP, BGP versus IGP, BGP security vulnerability analysis, and some of the best practices to address these vulnerabilities. So what is BGP? Like why and where we use it? So BGP is actually used to connect different autonomous system numbers to exchange the routing information. But before we go into deep, what is exactly an autonomous system number? So an autonomous system number is a group of IP network with a unified routing policy, and that network is managed by one admin or entity. So in case of BGP, we actually use it to share the routing information between different autonomous system numbers. Like in this case, you can see AS20 and 30. They need to establish eBGP session, and then they once they have established session, they advertise their prefixes, and as a result, they get the traffic from the other side. So advertisement of the prefixes and traffic, they are actually opposite in direction. So once you advertise your prefix, as a result, you get the traffic. We have another protocol which is IGP, and this is actually we need to understand why we use IGP and why we use BGP. So if we see the difference between them, so IGP is only used to exchange the routing information within an autonomous system number, and we should use only to carry the infrastructure prefixes. We should not carry the customer or internet routes in IGP, because the idea is to have less number of prefixes and achieve better scalability and faster convergence in case of IGP. If we take a look into BGP, so there are two kinds of BGP session we have. One is the iBGP, another is the eBGP. So iBGP is used to exchange routing information within autonomous system number, and it is used to carry internet routes and the customer routes. eBGP, on the other hand, it's used to exchange routing information between different AS, and we use it to advertise our prefixes and the customer prefixes, and it also help us to apply the policy, so we have some sort of control over the advertisement we do and what we receive from the others as well. So the other protocol IGP actually does not provide any kind of control, so that's why whatever you once you have established the session, you do not have any sort of control to control the flow of the routing information. So that's why BGP is used in case of internet, because we need to control what we advertise and what we receive from other, and that make it different from the IGP protocol. But there are some built-in problem in case of BGP. So one is like the routing works by rumor, and we actually have to trust others, and there is no built-in security mechanism to verify what others are advertising. So we need to assume whatever they are advertising us, that's correct, and they are honest in their advertisement, and there is no inbuilt mechanism to verify the correctness of the prefixes or the AS path we are receiving along with the prefixes. So if we take a look into the BGP, so there is there is some security vulnerability analysis for the BGP. So that means there is built-in inbuilt some loopholes within the BGP. and there is no method or which we can use to check like protection of the messages or integrity of the messages, and we cannot authenticate them as well. And we do not have built-in mechanism to validate a authority of an AS to announce the certain prefixes, and there is no built-in mechanism to verify the AS path attribute to validate it or authenticate it. So how we can address these vulnerabilities in case of BGP? So there is an RFC 7454 which actually described about the best practices that we can should be using to enhance the security or routing security in case of BGP, and avoid the loopholes, and secure our session so we do not run into issues when we are using the BGP. So one of the primary thing is to protect your BGP speaker. So we need to apply the data plane filter to block the spoofing of the packet, and we should also use the control ACL on the control plane to block the unauthorized access. So like someone is trying to establish a BGP session with your router, and he is actually not a legitimate speaker. So how you can protect your own router? So if someone is trying to send you the request over the TCP port 179, you should use the ACL and only authorize the legitimate speaker to send you the BGP request. The second is we should also have some sort of the security, and we should be using like MD5, which is described under the RFC 2885, or it's ideal to use the TCP authentication option under RFC 5925 for the peer authentication. So the preference is for the TCP authentication option over the MD5 because of the strong algorithm it has, and there is option to rotate the key during the session without bringing down the session as well. The next thing which we should be doing is the route filtering. So we need to filter the routes when we are advertising or when we are accepting from other. So what we need to do in this case, we should implement the prefix list filter and AS path filter is, and we need to deny the bogan routes. So the bogans are the routes which should not be routed towards internet, and we should not exchange while having the eBGP session with others as well. We also need to control the flooding of the prefixes. So we need to set the max prefix limit on our BGP session with other organizations. So accidentally, if they announce a large number of prefixes or there is any leakage from their side, so our peer or our router is protected, and we do not get the garbage, and they are not able to flood the wrong information to us. The next thing in the line is the registration of the routing information in the IRR database. So actually, we should be creating our routing policy information under the APNIC object. So the other organization, when they are doing the automation, so they can use this object to know what are our downstream customer, for those we are going to advertise or act as a transit, and they can build up their actually AS path list, filter list, and the prefix list based on this AutoNum object. The next thing is like in case of IRR database, there is some loopholes. So actually, sometimes people do not update it for a longer period of time, and there is not even there are many IRR database which are maintained by the entities which are not the regional internet registries, and you will find some old entries which are outdated as well. So we actually do not get very like accurate information from the IR databases, which are like more than 60 in this case. So in that case, there is another mechanism that is more secure and more updated as well. So we should be using the RPKI validation in this case. So there are two things we need to do to enable the RPKI validation. First thing is like everyone should register their roots in the RPKI to they should have created in the IR database the ROVA object against their prefixes. So what is in case of ROVA, we'll see in the upcoming slides. We should need to create the ROVA for our prefixes and with our AS number, which we are going to actually use to advertise the prefixes. So once you have done, that means if someone has deployed the route origin validation, so then he can check the advertisement that you are doing, and he can see if those are valid, and if those are not valid, not according to the ROVA object, so he or she can reject the invalid routes. So in this case, you are protected against the hijacking of the routes. So someone actually cannot hijack your routes and advertise your prefixes with their ASN. The other, there is some configuration example I have, like how to block the spoofing. So there are two modes we can enable on our devices. One is the strict mode, another is loose mode. So in case of strict mode, actually the router will verify the packet from which interface it has received. It is the same interface from where it has received the route as well. But if you are using multi-homing, like you are using two different interfaces between you and your BGP speaker as well, so then the packet can come from any of the interface. Then in that case, you should use the loose mode. So here we have the configuration example for both Cisco and Juniper. So how we can protect our TCP 179 port? So we should configure the ACL, and then we should attach the ACL to the control plane. So this is an example for Cisco and Juniper. So we are saying permit TCP host 10.10.10.2, which is our trusted peer. And if he's sending the request to, like in this case, example is 192.168.1.1, and the port is 179, then we should accept, and we should not accept the BGP request, session request from any other, and you keep on updating this list based on your peers. So there is another way, like how to use the TCP authentication if your device does not support the MD5. So then you should be using if you TCP authentication, you should use the MD5. Otherwise, TCP authentication is the preferred option in this case. So this is an example for Cisco and Juniper, like how you can configure the TCP authentication on these devices. Another thing, like I said earlier, like we need to drop the bogans when we establish the BGP session. So regardless of your BGP speaker, it's your downstream or it's your upstream, or you have a session over the internet exchange point, or you have a bilateral peering. So we should need to drop the bogans when we are receiving and advertising IPv4 and IPv6 prefixes. So in this case, just I have the listed here the IPv4 list of the prefixes which are considered bogans in case of IPv4. Similar, we have the IPv6 as well, but due to the time I was in this presentation, we cannot have those. So we should also use this list and match these prefixes when we are receiving and advertising the prefixes, because these are the prefixes someone should not advertise to others. They are the special use prefixes. So you can see here the comments, like what are the different purposes for these prefixes they are used in a network. Other than this, we should also consider when we are filtering, we should filter anything which is longer than /24, like 25 and up to 32, and we should include our own prefixes. You should not expect your prefix from someone else, so someone else should not be advertising your prefix back to you, so you should drop that. And keep on updating this list, because sometimes there are new prefixes which are assigned by different bodies for the special purposes. So how we can automate the prefix list when we are actually going to establish a BGP session with one of our customer. So if like I am going to give a services to a customer, or I am going to establish a BGP session over the internet exchange point with another peer, so I should only accept the prefixes that he actually owns, and should not accept the prefixes which are not owned by him from their side. So there is a tool which you can use, like BGPQ4. Earlier it used to be BGPQ3, but nowadays the latest is BGPQ4. So in this case, like I want to create a prefix list for AS45192. So I have given the command BGPQ4-6, means create address family IPv6. And then I'm saying that for BERT, so the operating system could be BERT, Cisco, Juniper, Arista, Huawei. So you can check the different keywords that you can use. And then L is to specify the name of the list. So in this case, this it will create this list as well. So it will go to the IR database and then create a list for you. And instead you do it manually, it will be automatically done for you, and you have less chances of error as well. But you should remember in this case, when we are using the BGP Q4, we should be using the source and specify from which IRR database we want to get the records. So in this case, you can see when I have not specified the source, the prefixes I have, there are 5 prefixes, but when I am specifying the source, I am just getting the 3 prefixes. That's been by default. It does not use the APNIC, and it use the RADB, and you get more prefixes which are not actually accurate and not updated as well. So we should be using specifically the internet registry from which internet registry this AS block, AS number belongs, and then we should generate the prefixes from there. So this actually help you quickly generate the prefix list, and you do not need to ask your customer or peers, and this is more accurate in this case, and you can later on share with them as well, so they can verify it. Another way is like we should also create a filter list for the AS path. So we can use the AS set, and then it actually checks the whole AS set, and whatever the AS set members are there, it will put them at a origin, and you can also specify which is your peer AS. Like in this case, the scenario is I'm going to peer with 45192, and then these are we are assuming like the AS set from where this AS is going to receive this prefixes. So in this case, when I will receive the any prefix, the peer AS, it should be 45192. Then any other AS can appear after this. There could be a space. It could appear and it could not appear, because the steric mean it can come and it cannot come as well. And then there would be a space, and then any one of them should be the origin AS or the first AS in the uh, AS path attribute. There is another tool you can use to verify your regular expressions when you create it. Actually, this tool is for the different languages, but even we can use to check it for the BGP AS path regular expression that we can create. So you can go to regular expression 101 website, and there you can paste your regular expression, and then at the bottom you can specify the test string, the different AS path you are expecting from your neighbor, and then you will see whatever is going to match according to this regular expression, and on the right hand side here you have the explanation as well. So this help you to create the accurate regular expression what you are expecting before you apply to the your router the configuration. So earlier I said like we need to create ROVA. So what actually ROVA look like? So in that case, this is actually a digital assigned object which binds your prefixes with your autonomous system number, and you can verify this cryptographically as well when you have the when you apply the ROV as well, the route origin validation. So in that case, you when you create the ROVA, you specify the prefix, the max length, and the origin AS, and you can create multiple ROVAs, and they can exist for the same AS as well. So in this case, the important is the maximum prefix list and the AS and the prefix. So that's mean I am going to advertise the prefixes from this /29 up to 24, and the origin AS would be 17821. So in case of validation, how the validation is done. So we have example network here and topology where we have AS821, which is advertising an IPv6 prefix 2406 colon 6400 colon /48. And it is advertising to its peer, and then the peer is advertising to next peer, and finally it reaches to this autonomous system number. But there is a another bad guy who is advertising the same prefix, and it is also reaching to this network. So now, due to the shorter AS path, the wrong advertisement, this is selected as a best route. How we can avoid this? So if we have the RPKI validator in our network, and so in that case, actually the RPKI validator, it gets the copy from the global RPKI repository, which are the 5 regional internet registries. So it gets the copy of all the ROVAs from there, and then it actually build a validated cache, and then provide this information to the router as well using the RTR protocol. So now the router has the information like the this prefix 24066400 /32, and it could be up to 48, and the origin AS should be 17821. So it knows like from the RPK repository, the origin AS could be 17821. It cannot be 65582. So it can actually it can validate this copy, and the other copy could be the invalid. So this is when you apply the RPKI information received from the repository, then you get the valid statement against this advertisement, invalid against this, and then based on the your BGP policy you can drop the invalid, and this is how you can secure or protect your network to from the wrong advertisement. So as a result, you whatever the traffic you was going to send, it will not go to the bad guy, it will go to the original owner of the prefix.